All right, what's up, everybody? Welcome to Red Science, of course, and welcome to page 7 of our Isolines packets. So I'm going to just take a quick aside on this one, just for the heck of it, break the monotony a little bit. What this one's having us do, this is a Regents question, is draw isolines for the 50, 100, and 150 part per million amount of contamination in the groundwater. So before I was a teacher, right? When I get out of college, I worked in this field for a little while. So I figured, what the heck, let's talk about it, because that's what the question is. This was up in the North Country somewhere. This is up, I think, past Watertown, up towards the St. Lawrence, where there was a gas station here as part of this plaza. There's like a PNC, or that used to be a grocery store. There's like a grocery store and a couple other things, typical little mini mall. And there used to be a gas station, and the USTs, underground storage tanks, were leaking. After working this job, I feel like everyone everywhere is leaking. It was kind of depressing, honestly. And when they leak into the ground, that enters the groundwater and spreads, depending on the soil, hopefully slowly, but spreads throughout the area. So there you go. Yeah, PNC Foods. It used to be a grocery store. So what we did as a company was we'd come in, and they have a big truck that could drill a little boring down. Talk about boring, right? That's the joke. We'll beat you to it. Drill down into the soil in 4-foot sections. They can go from the surface to 4 foot, and then you put an extension on it and go from 4 feet to 8 feet and so on. You dig down, you take samples of the soil. The environmental engineer then would take those and try to figure out how much contamination was in it, how deep it was, where was it, delineate it, take notes about the soil, and try to do a 3-dimensional map under the surface of where the contamination was. This was a surveyor I was working with that day. They'd come and map out the surface so that everything could be done very accurate, so that when it came time to figure out what to do, whether they excavate or try to do a pump and treat or whatever it is, they had an accurate map, So this is the setup, sucking water out of the ground and come through here. It's called a peristaltic pump. It would just, like a little wheelie that would just pump the water out. And then we put it in different jars for different tests, go back and figure out what the level of this contamination is. Pretty fun job, honestly. If any of this earth science stuff is appealing to you, thinking about future careers, the environmental engineering, we had an engineer in charge. That's a lot of schooling. That stuff, very doable for a lot of you. But there's all kinds of jobs around this. I did this out of college with an earth science education degree for a little while. You can see this is water right out of the ground going into a Home Depot bucket. Look at that. Gnarly. That's gas that didn't make it from, it made it into the tank, but didn't make it into people's cars, pumping right out of the ground years after the gas station had closed. And then there's all kinds of, you can also get into these careers on like legal fronts. And how does this affect property transfers? I was on one project where Mobil was willing to sell the property that they had to a town for $1 so they could build a park there. It was like, great, good deal. But if you buy that property for $1, you're buying that property for $1. What's down there? And they hired us, and it was a lot scarier than this. So yeah, that's cool stuff. And that's what this question is essentially getting at. That if we had a underground gasoline tank, usually we say UST, underground storage tank, and then this would be an awful lot of monitoring wells, but perhaps. And in this case, you can see that we were going to make it right down to a Lake Martin. Whether that's real or fake, I don't know. So, was all that babbling worth it? Probably not to all of you. Some of you just say, let's do it. Give me the job. I want to be done. I hear you. So your job then is to draw the 50, 100, and 150 isolines. Now, this one looks easy, but I've seen some crazy stuff on this one through the years. So why don't we do a quick pause and do it? Let me see. Should I say pause and do this whole page? Number 80. Don't panic if you're not doing that one right away. Why don't we do a pause, try this whole page. We'll come back and take a peek at the answers. All right. So pause in 5, 4, 3, 2, 1. All right. Welcome back. Thanks for pausing. Thanks for doing your work. You're such good students. I appreciate it. And I hope you're doing all right. I know this stuff is no fun compared to most years. So here we go. We got the 0, 50, 100, and 150s. So this would be the problem area. This would be where, depending on how deep this 50 part per million mess is, we can see that it is interacting with the lakeshore. Now, could I take this and loop it right back to itself? Yes, I could. But I'm going to end it right at the lake there to say, like, okay, that would be an issue if this, let's pretend it's a really steep shoreline, just because that would be convenient for boats and docks and all of that, right? So if that steepness of that shoreline gets to a point to where the contamination is hitting the water, then you're basically just this I don't know if this would be a state park or a business or whatever, but they're buying gasoline from gasoline trucks that come and deliver it. You've seen those. Stick the hose into the ground, they pump down into the UST, and then for every 100 gallons you're buying, maybe you're only selling 99 of them. The rest is washing into the soil and eventually down into the lake. All bad news, and all preventable bad news. It's expensive to fix. I'm not going to deny that, but fixable and preventable if you invest right at the beginning. Above ground storage tanks really honestly seem to be the easiest solution to me. That takes a little bit more space, and people that know more about cars than I do, which it doesn't take much, say that if those heat and cool, you can get like a buildup, especially if there's ethanol in it. You can get like a buildup of water, and maybe it's not as good for the quality of gas. So none of these issues are easy, but that's the deal. Excuse me. So what I'll see sometimes, if you want to talk about another classic rookie mistake, we haven't done a classic rookie mistake in a while, is the 100. People will do this, and then we'll take the 150 and do this. There's a problem. All right, so the 150 is the most intense, the highest level of contamination within the soil. If you're going to go from 150 down to 50, though, you got to pass by the 100. So this little part of this would be wrong. If you did that, that's okay. We're all still learning, but that's not correct. Better is to say, I know because I can count that if we're going to go from 50 to 150, that line's got to sneak through here like that. So that was flow region credit right there on that guy. However many points that was. So that was 78. 79. State the relationship between distance from the gasoline tank and the concentration of contaminants in the groundwater. If you remember the number of times I've said this, hopefully we do, whenever we got a relationship question, it's just a comparison question. They want to know, how do these two things affect each other? So just look in the sentence for the two things. They want to know, how does distance from the tank and concentration of contaminants affect each other? Those are nice straight underlines. How do we answer it? We always start with the same word, and that word is as. And then just say whatever the first thing is. Distance from the gasoline tank. Now, your choice, you're either going to pick increases or decreases. So you're going to say, as this first thing changes, how does that affect the other thing? I usually like to pick increases, though you can answer that with decreases if you'd like, as long as you do the second part right. So how does it affect it? As distance from that gasoline tank increases, what happens to the concentration of contaminants? Not hard to picture or imagine that the further away you go, just like going up to that barbecue map on page 2, the further away you go, in fact, this is almost the same exact map, the further away you go, the less there is, right? So as distance from the gasoline tank increases, tell me that second thing, concentration, that can't be spelled right. Of contaminants in the groundwater decreases. There we go. Or if you were like, no, I want to answer this with decreases here, as distance from the gasoline tank decreases, in other words, as you get closer, then the concentration of contaminants would increase. Park officials do not want to see another incident of groundwater contamination from the gasoline tank. State what action that park officials could take to prevent gasoline from contaminating groundwater in the future. We could go with above ground storage tanks, excavate and clean up the soil, ensure that they're encased in layers of concrete. There's always a question on the regions. It's like either like prepare for a disaster or what do you do in this instance? Just try not to be too fancy. Don't come up with something outlandish, and you'll get your 1 point. I really don't think too many people lose points on those. It's kind of a free point. What evidence is there on the map to infer what direction the groundwater may be flowing? That's a good one. That's actually not a regions question. That's been typed on there. This is almost like the barbecue map again. If you've ever been to a boat launch, you can probably guess that the parking lot is going to be uphill from the lake, right? Otherwise, the lake's going to drain down to the parking lot. That's not going to work. So we've got like a downhill flow here, and along with that gradient, the water is going to be flowing down towards the lake. Even underground, there's an underground water flow that takes place. A lot of us up where we all live have wells. You're used to that. That's where you're getting your waters from deep down on the ground. So yeah, if you own the property next door, like, oh man, I got this awesome lakefront property. How close are you to this guy that's dumping gasoline into the soil? So I would say that the flow is down towards the lake. So that'd be down towards the southeast. All right, we're through another page. Page 7. All right, next we're going to start talk about isobars and isotherms. Weather's actually getting into more of the meat of weather. But I'm going to take a break, of course. Don't pay attention to those page numbers. I rearranged just a little bit. So thanks. You're doing good. Keep it up. You're doing well. Keep it up. Time for me to take a break. I'm tired. All right, we'll see you in a minute.